Sorry class for the inconvenience because there is a technical problem. Alright, let us now proceed to the last rectifier circuit, which is full wave bridge type. We have here actually the output, which is across the RL, which is the same with the full wave center tap type. It is also full wave. And the frequency is also doubled. If we are going to be sure the frequency class, the frequency is 120 Hz. See, 120 Hz. Also, at the primary and the secondary winding of this transformer distribute 6 Hz. But at the output of the rectifier circuit, the frequency is doubled. That becomes 120 Hz, the same with the full wave center tap type. Now, which among these two types is advantageous to use? Full wave bridge type or full wave center tap type? It is advantageous to use center tap type in the sense that it uses 2 diodes only, and it is more efficient, and the power is a little bit higher compared to the bridge, which is a little bit complex in the sense that you are using 4 diodes already. No? Okay. It goes like this, class. Both half cycles, positive and the negative half cycles, are allowed to pass. In the first half cycle, the polarity at the second winding goes like this, positive here, negative here. Now, which of these two diodes are conducting? Of course, this diode 1, in the sense that anode is connected to the positive side of the second winding, whereas cathode is reverse bias. This diode D3 is reverse bias. What is forward bias is D1. So, it goes like this. From this zero or negative polarity of the transformer's winding, it goes like that. So negative, it shouldn't be here. It should be here, because cathode is forward bias to this negative side, not this one, because this is anode. So it goes like here, then going down, then passing the RL, then D1 going to the positive side. So the output goes like this. The first half cycle is allowed to pass. But in the next half cycle, the polarity changes from positive to negative. And the negative here goes to positive. Goes positive. So, among the four, only D1 and D2 are conducting, whereas D3 and D4 are not conducting during the first half cycle. But in the second half cycle, which is negative going, the polarity changes. So, the flow of the current goes like this. It always starts at the negative side. So, it goes like this. Then, this diode is reverse bias because anode is positive, whereas this is negative. So, it flows through this diode D3. Then again, going to the RL. Then, here, D4. Because it cannot flow here because it is going back to the negative side. So, it should be here. Here. So, both half cycles are allowed to pass the same with the full wave center tap type. Then, in the next half cycle, again, the polarity changes. From negative, going back again to positive, and the positive going back again to the negative. Again, the two diodes, D1 and D3, will be conducting. D3 and D4 now will not be conducting anymore. So, there is an alternate conduction of the 4 diodes. The first 2 diodes, D1 and D2, are conducting at the same time during the first half cycle, while D3 and D4 are not conducting. But in the next half cycle, which is negative going, D4 and D3 now are conducting, whereas D1 and D2, which are conducting a while ago, is now not conducting. So there is alternate conduction of the 2 pairs. The first pair, D1 and D2 are conducting, while D3 and D4 are not conducting during the first half cycle. But in the next half cycle, D1 and D2 will no longer conduct. What will conduct is D3 and D4. So there is alternate in operation. But both half cycles are outputted across RL. So the frequency is doubled again. So again, which among these two, full wave bridge type or full wave city type? Full wave city type is better because bridge uses 4 diodes, which is the wirings are a little bit complex and the power is a little bit lower. But the efficiency is the same. The efficiency of the output voltage for both bridge and center tap type. Okay class, let us now, actually, it should be taken into account the diode parameters. We have to consider them before we are connecting them to the circuit. There are 4 diode parameters. These are the peak inverse voltage. That is the maximum voltage of the diode at the reverse direction. Remember, at the forward direction, it is only 0.6 volts for the silicon and only 0.2 volts for the germanium. But actually, we are using silicon. But in the reverse direction, that is, diode is connected at the reverse direction, we call it peak inverse voltage, the maximum voltage at the reverse direction that the diode can handle. Okay. Actually, the output voltage here of the secondary winding of the transformer is 12 volts. And we are using 1N4001, which is 1 ampere. But the peak inverse voltage based from this diode manual, it is 50 volts. So meaning to say, this diode, wherein the peak inverse voltage is 50 volts, can handle the voltage distributed by this secondary winding because it is 12 volts only. However, if the voltage outputted by the secondary to be rectified by this diode is 150 volts, so this diode is no longer capable because the peak inverse voltage is only 50. So it will destroy this diode. So we have here a diode manual which will guide you. So we have here 400 volts, 200 volts, 1 ampere for 1N4003. Instead of using 1N4001, which is 50 volts only, the peak inverse voltage, we have to replace it with 1N4003, which is 200 volts. If in case the voltage output at the secondary is 150 volts, so the peak inverse voltage of the diode should be above with the applied voltage. No, that falls under peak inverse voltage. Actually, if you don't have available diode which is 150, you can connect 3 diodes, 1N4001 with a peak inverse voltage of 50. You can connect them in series. 50 plus 50 plus 50, that becomes 150. And it is already enough to control the voltage outputted by the secondary winding, which is 150 volts. No, that falls under peak inverse voltage. And among the parameters of the diode is maximum forward current. You can notice, class, that the physical sizes of this diode are of different sizes. We have here 3 amperes. We have here 6 amperes. Right now we are using 2 amperes. Then there is another 1 ampere diode, which is the smallest one. The smallest one, no? Diode, rectifier diode, which is... Okay, we have here 1 ampere diode, the smallest physical size, followed by 2 amperes, a little bit bigger, followed by 3 amperes, and we have here 6 amperes. The maximum current rate of a diode is 30 amperes based from this diode manual. Now, that is the maximum forward current. When do we use this current rate, the physical size? If in case you are using bigger transformer, for example, this transformer is 6 amperes. 6 amperes diode. 6 amperes, the current rate of this transformer. So, what is the appropriate diode that you are going to use is this diode, 6 amperes also. No? Because 6 amperes diode can handle the intensity of the current distributed by this transformer, which is 6 amperes. Because if you are using 2 amperes or 1 ampere, the diode during the operation will become very hot. because the current rate of the diode is not enough to control the intensity of the current rate outputted by the transformer. 6 amperes, then you are using 2 amperes. These diodes will become hot until it destroys the diode. No? Okay, that falls under the current rate. Just in case you don't have available 6 amperes, you may connect 2 or 3 amperes diodes in parallel to increase the current rate. This is 3 amperes, 3 amperes. Connecting them across each other will increase the current rate. 3 amperes plus 3 amperes is 6 amperes. Connect them in parallel. But if you are connecting them in series, the current become lesser. What is increased actually is the peak inverse voltage. This is 100 volts plus 100 volts, that becomes 200 volts. It increases the peak inverse voltage. If it is applicable when the voltage to be rectified is 200 volts, because 100 plus 100 is 200. But what you're looking for is the current rate of the diode. This is 3 amperes and 3 amperes. So connect them across each other so that it becomes 6 amperes, which is in accordance to the current rate of the transformer. Okay? What else? The power dissipation. In linear diode, there is a power rating that is in accordance with the physical size also. No? 1 watt, 2 watts. And the maximum temperature. Because diode actually, during operation, will become hot. Among the two types of diode, germanium and silicon, germanium is a little bit higher in temperature to be dissipated. No? To be controlled. Because it reaches to 200 degrees Celsius for the germanium. Whereas for the silicon, it is up to only 110 degrees Celsius. No? But when it comes to amplifier, germanium diode is better because the biasing voltage is only 0.2 volts. Diode can be activated with a little amount of voltage because 0.2 volts only, whereas for silicon it's 0.6. No? Actually, germanium diode, crystal, we have here signal diode, crystal. This is actually made of germanium. It is very applicable when it comes to detection, signal detection or signal demodulation. Because what is inputted, the signal, the amount of the signal that is inputted to the circuit is below, somewhat below 1 volt. No, below 1 volt. So, germanium is better compared to silicon. If the voltage that is inputted to the diode is only 0.4, so silicon diode cannot be operated. Whereas germanium, since the biasing voltage is only 0.2 volts, it is operating. Okay? I think that's all for now, my dear students. If you have queries and suggestions, please do not hesitate to send to me or to send me, because valid and good queries deserve good responses. Thank you and goodbye, class.